All right. Hey, everybody. It is Professor Cooper again for data visualization. We're going to talk about join functions. This should be a pretty quick video. Uh, it's really important in your data management skills to be able to merge two data sets. Another way to say that in programming is to join the data sets. Now, there's a suite of join functions in dplyr just for this purpose. And in my experience, they're way more flexible than the base R merge function. So I'm going to go through a working example of the join suite with full join, left join, right join, semi-join, and anti-join. And I'm going to build two small fake data sets, and we're just going to go through the examples so that you can see exactly what the join function does and the arguments and how it works. It's pretty simple. Okay, so I make two data sets, two little fake data sets. They're just some vectors. One of them is a vector of numerics, and then characters, and then integers. And I define these, and then I do the same for the second, and I just have some overlapping names, but they are not all overlapping. And then I define them as data frames here. So you can see the first one will end up looking like this. Why ABG, you ask? Because I originally did ABC, D, E, F, and then realized that you should never mistakenly name an object or a vector after a function that is as important as C. So I changed it up to G. But then we have DEF for the second data set, and we produce that, and it looks like this. So these are our two data sets. As you can see, there are some of the names, two of the names in each data set should match up. So in theory, we could do some kind of a merge on these data. And the variables that we're working with here are of the same types, but the only one that will match up is the key variable, which is the B and the E. They don't have to be named the same thing. They don't have to both be called name. I don't have to rename them. But we're going to join these two data sets, and we're going to do it, and we're going to go through all the different kinds and talk about the results. Okay, so full join is the most flexible. It's going to keep all the observations, and for anybody that doesn't match, they're going to get an NA for the variables in the matching data set that they don't have. Okay, so we're just going to go through with an example. So we're going to go full join, and full join, so the arguments are the left-hand or X data set, the right-hand or Y data set. Don't let it fool you that this is Y and Z that I called them. This is the left-hand side or the X data set, and the right-hand side or the Y data set in terms of the arguments. Then we have by equals, and then if the two matching key variables, if the key variable had the same name, we wouldn't need this concatenate. We could only just put the one name. But because they're different, you can put them inside a concatenate, and in quotations, put the names of the two variables with an equals in the middle. So you can say B should be the same as E. That's the matching key variable. Right? Okay, so we're going to run it. Okay, so as you can see, if you look back at Y and Z, Javier, Gustav, and Beatrice, and then Sandrine, Ahmed, Gustav, Beatrice. Oh, I forgot Amy and the other one. And so obviously Gustav and Beatrice should be the match. We look at full again. They have observations on all the variables. Amy and Javier were not in the second data set, and you can see from D and F that those variables were carried forward into the join, but they were left with NAs. because they were actually not in the data set. And the same goes for Sandrine and Ahmed in the first data set. Right? You see the NAs on A and on G, which were from the first data set, even though Sandrine and Ahmed are from the second data set. So it carries forward. It's very flexible. It does produce some NAs. Some depends on what you're doing and whether or not that's problematic. In many cases, it won't be, but it may potentially be sometimes. So you might want to use one of the others. And here are the ones that we have available. We have left join, which favors the X data set, or the left-hand side. So Y is going to be the one that predominates here. So everything is the same in terms of the arguments. The only thing that is different is full join to left join. And we run it. And you can see we only have 4 observations this time instead of 6, because the only observations that carried forward into the join were the observations from the first data set, the one on the left-hand side, the X, in quotations, data set. So they either got a match or they didn't, but in this case, left join throws away the right-hand data set observations that don't get matched. Okay, as you can imagine, the same thing can happen in reverse with right join. So let's do right join. Same arguments. So the 4 observations that are carried forward into the join are the 4 observations from the right-hand side, or the Y data set. And so that's Sandrine, Ahmed, Gustav, and Beatrice. And you can see that NAs were produced for the variables that carried forward, but had no observations for Sandrine or Ahmed, but had observations for Gustav and Beatrice, which were the ones that matched across both data sets. Okay, so let us now see what semi-join is. Semi-join is going to tell you the things that we know are going to match across both data sets. So it is a subset that will get a complete match. This is what you know will be matched. It's good to look at, but even as important, and perhaps more important, would be the anti-join. This is a really powerful little function. It's very useful for data management. This is going to tell you what doesn't match, and it's going to do so in order. So if we put the Y data set and then the Z, or actually the left-hand side and then the right-hand side, and by B equals Z, which were the 2 variables that had the names in them, and we run it, we're going to see only Amy and Javier come back. Those are the observations in the left-hand data set that did not get a match. That's only for the left-hand side. So in order to see the right-hand side, we can simply reverse it and do an anti-join where we put Z on the left-hand side and Y on the right-hand side, and switch the variables to E equals B, because they're supposed to match this side to this side, and this side to this side, left to left and right to right. All right. And now we can see that this anti-join shows Sandrine and Ahmed are the ones that don't get joined. And they are now on the left, so they're the ones that we see. And that's really it. And this is a leftover from a plotting environment, so please ignore that. So that is the story on the join suite in a nutshell. It's really powerful, really useful. When you're merging data sets, don't merge them in a literal sense with the function merge. Merge them with join. And I always start with full join, because it's better to do that and not throw away observations. But if you know that you only need the observations from one or another data set when you're merging, you can use left or right join. And then you can also look at the ones that are going to get a pure match with semi-join, and then the ones that won't match from the left side, so you flip it back and forth with anti-join. All right, that's it. See you on the flip side.